Okay, we're going to try to do 1.5, problem number 24. Alright, so for problem number 24, we're given the following function, and we're asked to find the inverse function. Okay, so the way that we do that is, first let me write down the function because it's kind of complicated. It's a rational function. So I'm going to get x equals, f of x equals x plus 3 all over x minus 2. And so probably it's, before I waste a lot of time on that, first thing that we want to do is let's go ahead and verify that that is even a one-to-one function. That would be helpful if we knew that information. So I'll turn on my calculator. Now remember, the numerator is a group, so I want to say x plus 3 in parentheses. Close my parentheses. Whoops, you got to hit the plus sign. X plus 3 divided by x minus 2. Oh, I must have worn out my plus and minus signs. All right, there we go. And so now if I graph that, remember that on your calculator, when you have a straight line like that, that's representing a vertical asymptote. And that occurs at x equals 2. In other words, if you look at this, right, x can never equal 2 in your domain, right? And so that's why we got that funny little vertical line right here at x equals 2. But if I draw a horizontal line through this function, it only crosses one time because it looks like there's also a horizontal asymptote that occurs right here, probably at 3 if I were to guess. Because no matter what value I put in for x here, my lowest y value could be maybe 3. Well, I don't know, I shouldn't say it that way, but actually no, it approaches 1 because these two values or powers of x are equal. So you always go by the leading coefficient. So we have a horizontal asymptote at y equals 1. So basically this is a one-to-one function, believe it or not. So we did all that, passed the horizontal line test. So since we know that it's a one-to-one function, right, so we'll say 1, 2, 1, yes. Okay, since we know it's a one-to-one function, we rewrite the function x plus 3 all over x minus 2, but we replace the function notation by putting a y in for f of x. The very next step that we would do is wherever there is a y, we put an x, wherever there's an x, we put a y. So we rewrite the equation x is equal to y plus 3 all over y minus 2. All right. So to solve this is the tricky part. How do we get the y's by themselves on one side of the equal sign and get x on the other side? So this needs to look like y equals some stuff, right, to find the inverse. So everything in red is going to be my f inverse. Okay? The minute I flip-flop those x and y's around, I'm starting to deal with my f inverse function, right, my inverse of f. So now, if I cross multiply, if I think of this as x over 1 and I cross multiply, I get the quantity x times the quantity y minus 2 is equal to y plus 3. Now remember, our goal is y equals some stuff. And we don't normally do this when we solve equations, but the only way I'm going to be able to move this y back over to the other side is I'm going to have to distribute the x through the parentheses. So I'm going to push this through, and I'll get xy minus 2, x is equal to y plus 3. Then what I'm going to do is I'm going to subtract 3 from both sides to move the 3 away, and I'm also going to subtract xy from both sides. And what that will do is these will cancel on this side, the 3's will cancel on this side, and I get negative 2x minus 3 is equal to negative xy minus, or I'm sorry, plus y. I'll just pause there for a second so that you guys can kind of digest that. Make sure that makes sense to you. Okay? And if it does, then what we can do is we can move forward. I'm going to factor out a y on this next line. So if I pull the y out, I'm left with negative 1x plus 1. Or negative x plus 1, however you want to look at it. And then over here I've got 2x minus 3. Negative 2x minus 3. So then in the next line, what we would need to do is we would say, all right, let's divide everything by x, negative x plus 1 on both sides. Negative x plus 1. And so our next equation will be negative 2x minus 3 over negative x plus 1 is equal to y. That's it. That's our inverse. So our inverse then would be, and we could rewrite it so it looks a little more familiar to us. The inverse of that function is equal to negative 2x minus 3 all over negative x plus 1. Now if you don't like negatives for your leading coefficients, you could factor out a negative 1 on both those, but you don't have to. If you want to leave them that way, that's fine too. Okay, so now how do we verify that? Well, if we come in here and I plug in this equation in my graph, so we pull up our old graph, and then on the next line I plug in the exact same equation, I should get some symmetry across the y equals x diagonal line. So let's do that. So I'm going to say negative 2x minus 3 divided by negative x plus 1. Close the parentheses, hit graph. Now it's really hard to tell, but that is symmetrical about the axis. And by the way, I looked it up in the back of the book. This one's really kind of hard to tell. One thing you could do is remember that the function, so if we're trying to figure out a way to determine if this is the right answer, if this is the inverse function. Well, one of the properties that we know is that f of x, when you take an x value and you plug it into f of x. In other words, you have x and you plug it into the function and it'll spit out a corresponding y, right? Well, if I take that same y value and I spit it into the inverse function of x, it'll spit back out the original x value. So let's try that. So how do we do that? Well, what I can do is I can go in and we have both of our functions here. If I click trace, notice it says y sub 1 is x plus 3 all over x minus 2. I can arbitrarily plug in a value for x. So I'm going to plug in negative 3. Okay, so now what that's telling me is that if I have my function, if I let x equal negative 3 and I plug that into my function f of x, it's going to spit out a y value of 0. Y equals 0. Now, if I plug in 0 into my inverse, I should get 3. So now if I switch functions, and you can switch functions by hitting the up or down cursor, now I'm on my inverse function, and if I plug in 0, I should get negative 3. And I do. So that's another way that we could verify and make sure that we've done it correctly. So if you did that with 2 or 3 points, in other words, you plugged in an x value into your original function, it spit out a y value. Then you take that value, plug it into your inverse, it should spit out the value that you started with, right? Because the inverse function should undo what the original function did. Any questions?